Hi, my name is Ken Boss. I'm the Vice President of Sales and Marketing with J.N. White. I want to talk to you today about Esd Electrostatic Discharge and some things J.N. White does in the design of our membrane switches and user interface to help protect against Esd. Electrostatic discharge is simple. As a user, you're carrying static discharge. It can be more intense in some situations than in others. What all manufacturers don't want is a user to push a button and have that electrostatic discharge transfer from the human who's interfacing with the product through the graphic overlay and membrane switch panel and into very costly and sensitive components inside the product. It is for this reason that we focus on Esd for many applications in our membrane switch user interface design. This was one of the first projects we did for a customer, a medical device manufacturer that was really concerned about Esd. What this customer decided to do was use copper flex, because with copper flex you can build in a ground plane much like you can a printed circuit board. And they decided to do it in two different layers. They essentially did one layer for the switch or the keypad portion, and then they did a second layer for the LEDs. That segregated the LEDs from the switch layer, and we were able to protect those LEDs much more easily with this type of design. In addition to using copper flex in two layers, the customer also built in a static shield. So you can just see the tail of it here. This is an aluminum shield right underneath the graphic overlay that's designed to pick up any static charge that the user might apply to a button and dissipate it off the surface of the switch into the product where this shield is typically grounded out. This shield tab is grounded out. Last but not least, on this particular design, the customer had issues with static around the hole in the housing that these tails feed through. So what they had us do was, prior to putting on the connectors, we put this ferrite piece on here. So it's the combination of the two circuit layers, both on copper flex with the LEDs segregated, the foil aluminum shield underneath the graphic overlay, and the ferrite that allowed this particular switch assembly to pass 10,000 volt kV testing. I want to talk about a recent design J.N. White did relating to Esd and protection against Esd in the user interface. It starts with this copper flex circuit, the base of the design for this control panel. It was critical to this customer that Esd sensitivity be paramount in the design of the product. They really needed a design so that the individual user interfacing with the keypad, the end product, would not transfer Esd from their persons into the product and damage real sensitive components. We started from the ground up and built all of the protection into this copper flex circuit. What's unique about this copper circuit is that it's three layers. The middle layer is the layer we're using to design and work with the keypad portion. So the middle layer contains all the pads for the buttons, and it also contains all of the pads for the LEDs and embedded components. The top layer is a shield layer that you can see in this particular sample. It's the grid work pattern. Now what's unique about this is we also did the same thing on the bottom layer. So if you look at the back of this circuit, you can see the same grid pattern. So what's happened here that makes this quite unique is that the top grid pattern, or the top shield, is connected to the bottom shield through what we call stitching in copper flex manufacturing. So there's holes all around the perimeter of the circuit that are connected top layer to bottom layer through vias that make an electrical contact. So what's happening here is that the top shield layer is connected to the bottom shield layer with all of the electronics in the middle through that stitching process, and it actually acts as a Faraday cage. But that wasn't enough for this particular customer. What they wanted was protection against the individual components themselves should a static charge get into this product. Each of the components at each of the LEDs, there's a resistor built in right next to them. They're connected electrically, and it's essentially that resistor that will catch and reduce any electrical current that's on its way into the components themselves.